The most common types of motors used in split air conditioner fans are 1. Fan with constant speed induction AC motor. This is the most common motor used in fans located in the outdoor unit of traditional air conditioners. They operate through a rotating magnetic field that induces a current in the rotor, causing it to spin. They are reliable and relatively inexpensive, but have lower energy efficiency compared to other types of motors. Their start and operation require a capacitor. Basic control is done through relays. They use 3 wires of the same thickness. One connects to the common pin of the internal coils, another to one of the coils, and the third to the capacitor. Their most common failures occur in the capacitor, relay, and bearings. 2. Fan with multi-speed induction AC motor. These are the most common in fans of the indoor unit of older split air conditioners. They operate through a rotating magnetic field that induces a current in the rotor, causing it to spin. They are reliable and relatively inexpensive, but have lower energy efficiency compared to other types of motors. Their start and operation require a capacitor. Their power and each speed control is done through relays. They use 3 basic wires plus 1 wire for each additional speed that connects to the motor's common. Their most common failures occur in the capacitor, relay, bearings, and loss of a specific speed. 3. Fan with induction AC motor, electronically controlled by a triac. They operate through a rotating magnetic field that induces a current in the rotor, causing it to spin. Their start and operation require a capacitor. Their control is done through an electronic circuit mainly composed of a triac and an optocoupler circuit that allows switching on, off, and speed control. For switching on and speed control, they use 3 wires of the same thickness. One connects to the common pin of the internal coils, another to one of the coils, and the third to the capacitor. The speed variation is done by varying the supply voltage, manipulating the voltage curve. They require a speed sensor, called a Hall effect sensor, which connects to the electronic board through 3 very thin wires, independent of the motor's power wires. Their most common failures occur in the capacitor, triac, bearings, and Hall effect sensor. 4. Brushless DC motors, BLDC. These motors are becoming more popular in modern split air conditioning systems due to their high efficiency, lower energy consumption, quiet operation, and durability. The speed variation is done electronically with great precision, as the operation of these motors is similar to a DC motor but without the use of brushes. The indoor unit fans have the electronic board inside the fan. They generally have 5 connection wires with the electronic board. Red high voltage power wire, usually 300 volts. Black ground wire with 0 volts. White power wire to the electronic controller inside the fan, usually 15 volts. Yellow signal wire from the electronic controller of the outdoor unit board to the electronic board inside the fan. Blue wire indicating the speed and position of the motor shaft to the controller of the outdoor electronic board. In contrast, the BLDC motor used in the outdoor unit generally has 3 wires because its electronic board is inside the outdoor electronic board located in the outdoor unit. The 3 power wires are usually high voltage, ground, and speed signal from the exterior. The most common failure is located in the integrated circuit or IPM module that supplies power to the fan motor.